Hello everyone, my name is Bino. In this video, we are going to determine the general solutions of the following linear second order differential equations. And for this video, we are going to put the emphasis on the fact that the right hand side is equals to 0. Suppose we have the following linear second order equation where the a is multiplied by the second derivative of y with respect to x plus b multiplied by the first derivative of y with respect to x plus c multiplied by the y, and where the right hand side is equals to 0. We start by determining what we call the auxiliary equation, where the second derivative of the y with respect to x will be equals to r squared, and if that is the case, then the first derivative of the y with respect to x will be equals to r, and the y itself will be equals to 1. So our auxiliary equation will be equals to a multiplied by r squared plus b multiplied by r plus c multiplied by 1, which will be equals to c, and the right hand side is equals to 0. We can realize that we have a quadratic equation in r. So the solution of this differential equation will depend on the nature of the roots of this auxiliary equation. There will be 3 possibilities for the roots of this auxiliary equation. The first possibility is that we have real roots which are distinct. So that is to say, the first root will not be equals to the second root. And the second possibility is that we'll have real roots which are equal, where the r1 will be equals to the r2, which we can just call r. And the third possibility is that we'll have roots which are complex, where r will be equals to a plus or minus I multiplied by b, where the I will be equals to the square root of -1. For the first question, the first step will be for us to determine the auxiliary equation. So the second derivative of the y with respect to x will be equals to r squared, and the first derivative of the y with respect to x will be equals to r. The y itself will be equals to 1. So from this equation, the auxiliary equation will be equals to r squared minus 7r plus 12 multiplied by 1, which will be equals to 12, and this will be equals to 0. We have to solve for r. So we factorize. The factors of that 12 will be equals to 4 and 3. That negative, we drop it down, and the sign which we must have in here, when we multiply it with this sign, it must give us that positive. So we have negative multiplied by that negative, which will be equals to the positive. So our r minus 4 will be equals to 0, or r minus 3 will be equals to 0. So the r will be equals to 4, or the r will be equals to 3. So we have the first case where the r are not the same, so the other one is 4 and the other one is 3. And in this case, when they are not the same, the general equation y will be equals to a multiplied by e raised to the power r1 multiplied by x plus b multiplied by e raised to the power r2 multiplied by x, where a and b are constants. So the first root we determined that it was equals to 4, so in the place of the r1 we substitute the 4, and the other root we determined to be equals to 3, so in the place of the r2 we will substitute the 3, This will be the general solution of our second order differential equation, provided that the roots are not the same. For our second question, we have to determine the general solution. We determine first the auxiliary equation, where the second derivative of the y with respect to x will be equal to r squared. And if that's the case, then the first derivative of the y will be equal to r, and the y itself will be equal to 1. So expressing this equation in its auxiliary equation, will have the r squared plus 6 multiplied by r plus 9 multiplied by 1, which will be equal to 9, and this will be equal to 0. So from here we are going to factorize. So the factors of the r squared, we have r, and we will have positive throughout, and the factors of that 9 will be equal to the 3 and the 3. So our r plus 3 will be equal to 0, or the r plus 3 will be equal to 0. So r will be equal to negative 3, or r is equal to negative 3. So we have roots which are equal. So in the case where we have roots which are equal, the general solution y will be equal to a multiplied by e raised to the power r multiplied by x plus b, and this time around we are going to multiply with the x because the roots are the same, and this we multiply also by the e raised to the power r multiplied by x. Our general solution y will be equal to a multiplied by e raised to the power r. So the root is equal to negative 3, and we multiply this by the x plus b multiplied by the x, and this is multiplied by e raised to the power r, and the r is equal to negative 3 multiplied by x, and a and b are constants. And since we are determining the general solution and not the particular solution, so we are going to leave our answer here. So the general solution will be equals to a multiplied by e raised to the power negative 3x plus b multiplied by x multiplied by the e raised to the power negative 3x. Our final question, we have to determine the general solution of this linear second order differential equation. So we are going to let the second derivative of the y with respect to x to be equal to r squared, and if that is the case, then the first derivative of the y with respect to x will be equal to r, and then the y will be equal to 1. So our auxiliary equation will be r squared minus 6 multiplied by r plus 13 multiplied by 1, which will be equal to 13, and this will be equal to 0. And in order for us to determine the roots of this auxiliary equation, we have to use the quadratic equation. So our r will be equals to negative b plus or minus the square root of b squared minus 4ac, and this is divided by 2a. So our r will be equals to the negative b, and the b is equals to negative 6 plus or minus the square root of b squared, and the b is equals to negative 6 minus the 4a, and the a is equals to 1, and the c is equals to 13, and this is divided by the 2a, and our a was equals to 1 is equals to 1. So r will be equals to negative multiplied by negative 6 will be equals to 6 plus or minus the 36 minus 4 multiplied by 1 multiplied by 13, which will be equals to 52. And we are dividing through by 2 multiplied by 1, which will be equals to 2. So our r will be equals to 6 plus or minus the square root of 36 minus 52, which is equals to negative 16. So we have a complex root, and this is divided by 2. So let's rewrite the square root of negative 16 as the square root of 16 multiplied by the square root of negative 1, and this will be divided by the 2. So our r will be equals to 6 plus or minus the square root of 16, which is equals to 4, and the square root of negative 1 is equals to I, and this is divided by the 2. So we'll have 6 divided by 2 plus or minus 4i divided also by the 2. So our complex root will be equals to 6 divided by 2, which is equals to 3, plus or minus 4i divided by 2, which is equals to 2i. And the standard form of this is equals to r is equals to a plus or minus I multiplied by b. So we can write this as 3 plus or minus I multiplied by 2. So our a will be equals to 3, and our b will be equals to 2. So in the case where we have complex roots, then the general solution y will be equals to e raised to the power ax into a multiplied by the cos of bx plus capital letter B multiplied by sin bx. So now let's substitute. So our y will be equals to e raised to the power ax. Our a is equals to the 3. And we have this capital letter A multiplied by the cos of B, which is equals to 2x plus the B multiplied, the capital letter B multiplied by sine of the small letter b, which we determined as 2x. And this will be our general solution. We are not going to determine the numerical value of the constant a and the constant b, since we are determining the general solution and we were not given any initial values. Thank you guys for watching up until this point. If you have any questions, do leave them in the comment section below. Remember to subscribe, like and share the channel if you find this content useful.